So far, we've seen that it is possible for numbers to count numbers. Numbers don't just count items. For instance, we can say five threes, five threes. If you say five threes, the five is telling us how many threes that there are. The implication is that five is counting the number of threes. Three is being counted, and it is being counted by five. That which is being counted is called countee, and that which is counting is called coefficient. In pure algebraic expressions, it has become necessary, very necessary, to find out what a coefficient of a countee is. That is especially because in algebraic expressions, the countees are not always given as constants. Instead, they are given as variables. How do we tell what the coefficient of a countee is in algebraic expressions? That takes us to the second lesson objective of this lesson. That is how to determine coefficients. Coefficients of countees in algebraic expressions. Please join me as I explain how to find out the coefficient of a stated countee in algebraic expression. In this section, we learn how to determine coefficients. If we're given a particular expression, mathematical expression, and we are told to isolate the coefficient of a particular countee, can we do that? If we cannot, let us pay attention as I develop this section. Please, to start with, follow me as I compare these four number operations with respect to coefficients. The first is 2x. Second, 2 plus x. The third is 2 minus x. And the fourth is x over 2. In each case, I intend to isolate the coefficient of x. Notice that all the expressions have x. In each case, I want to know what the coefficient of x is. X is here, x is here, x is here, x is here. Don't forget what x stands for. It stands for just any number at all. Since we don't know what it is, it can turn to anything. As a result, we'll call it variable. Don't forget. Again, we want to find out, in each case, the coefficient of x. So in the first case, what is the x coefficient? In fact, let me write in each case the coefficient of x. Please watch out. And here they come. In the first case, the coefficient of x is 2. In second case, it is equal to 1. In this third case, it is minus 1. In the last case, the coefficient of x is 1 over 2. You may ask, how did I arrive at these conclusions? I believe you want to know if you don't know. First, you may ask, why is it that in the first case of 2x, 2 became the coefficient? In the case of 2 plus x, instead of saying that 2 is the coefficient, we said it is 1. Also, in this third case, instead of saying that it is 2, we went ahead to say that it is minus 1. And how did I get this 1 over 2 from this expression to be the x coefficient? Obviously, you were expecting that as long as 2 comes before x, here, 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 especially that in every case, x will have 2 as its coefficient, at least in the first 3. It is very clear that the number structure of the first 3 appears similar, but the fourth one is obviously different. So you were expecting perhaps that in this first case, it is 2 that will be its coefficient, and the second case, the same 2, in third case, the same 2. But you were disappointed in seeing that in the second and third cases, instead of having 2 as a coefficient, to have 1 and minus 1. The question is why? Now, follow me as I reason it out. To start with, let me take your mind back to how the concept of coefficient started. Do you remember the definition of a coefficient? Obviously, if you have forgotten it, that is why you may not have found it easy to tell the reason why the coefficient of x is not 2 in this second case and third case. Also, if this fourth one is difficult for you to tell as to why its coefficient is 1/2, it is because you forgot the meaning of coefficient. But if you crammed that definition without knowing its meaning, it is also possible that that is responsible for your not knowing why these statements here are correct. If you remember the definition of coefficient, but you don't know its meaning, it is also possible that that is why you don't know how to isolate coefficients of countees. Again, follow me as I go back to the definition of coefficient. What is a coefficient? A coefficient is a counter that tells us how many things that there are is called a coefficient. Let me ask, is 2 counting how many x? In this expression, is also 2 counting how many x? By now, you must have begun to see a reason why 2 is not the coefficient of x. In the third case also, I ask, is this 2 counting how many x? And is this 2 counting this x? The answer is no. It is only in one case out of these 4 cases that 2 is counting the x. Alright. Since we have just been told or reminded that a coefficient is that counts how many things that there are, what it means is that a coefficient stays with countee in the same expression, and that expression must be a product. That takes us to a condition that we must see in a number operation before we can call a given number or is a number seen as a coefficient or not. Let me write that condition that you must see before you can think about coefficient or not think about it. And here comes the condition. It is coming as a caution. That is something to be careful with. It says coefficients exist only, see this only stressed. Coefficients exist only as part of product. I hope you understand that statement. What it means is that it is only out of products we get coefficients. Which numbers or number expressions in the past in this topic do you remember that will make you realize that coefficients actually must come out of as part of products? Let me remind you about just one of them, and with it alone you can remember all other ones. What is it? See just one example here. 5 bracket 9. I hope you remember what it is. It is called 5 nines. So is this not a product? It is a product. It simply means 5 times 9 or 9 times 5. So either way, the answer is 45. Anyway, if you say 5 nines, coefficient is any number that counts other numbers or counts other things. Which one is counting which in this expression? is 5 counting 9 or 9 counting 5? Either way, it is correct. But because 5 is written first, conventionally, it is taken that 5 is the one counting the 9. After all, 5 nines means 9, 9, 8 to 5. That means 5 is telling us how many 9s that we have. As a result, the coefficient of 9 is 5. Again, do not forget that 5 bracket 9 exists as a product. If I say 5 plus 9, the 5 and 9 no longer exist as a part of product. So it remains a rule that every coefficient is a part of a product. Now back to these challenges we have here. In this first case, is 2 a part of a product? Yes, because 2x means 2 times x. What it therefore means is that 2 tells us how many x that we have. This is why I brought a conclusion that coefficient of x is equal to 2. I hope that is clear. In the beginning, that statement was made and I did not explain it. I think at this point, you have come to see that the statement is correct. What about 2 plus x? X has a coefficient, but not 2. Surely, 2 is not the coefficient of x. Something else is its coefficient. Why? 2 and x do not exist as a product. 2 and x exist as a sum. And coefficients do not exist as a part of a sum. Instead, they exist as a part of products. Therefore, since 2 and x don't exist as a product, we do not state that 2 is part of the x coefficient. Instead, something else is multiplying this 1, this x, but not seen. Please, if you say 2 plus x, it simply means 2 plus 1x. 2 plus 1x. So it means that there is 1 here that tells us how many x that we have. But that 1 is not written. By convention, when 1 is a coefficient, we choose not to write it. So, but 1 is here, meaning 1x. Therefore, is it 2 that tells us how many x we have, or this 1 that is not written but exists here? Surely, it is that number 1 that is not written but which exists that tells us how many x that we have. 1x. That is only 1x. 1 tells us how many x we have. As a result, we conclude that the coefficient of x is equal to 1. I hope what is going on here is clear to you. So this is why we did not say that 2 is its coefficient. Next is 2 minus x. Please, what is it if I have to call it fully? It is 2 minus 1x. 2 minus 1x. Again, we did not conclude that its coefficient is 2. Instead, we said it is minus 1. So why is it minus 1? Obviously, if you learned why 1 became its coefficient in the second case here, you can also tell why minus 1 is its coefficient in this third case. Can you? Alright, let me follow along. As you reason, recall that 2 is not existing with x as a product. Instead, 2 exists with x as a part of difference. Because of that, we don't even count 2 to be its coefficient because 2 is not a part of a product. If the entire expression had been a product, then we would have considered 2 to be a part of product and then we call it its coefficient. Alright, so if we have 2 minus 1x, it thinks that there is 1 here again unwritten, and that 1 is minus 1. So, because of that, we say that the coefficient of x in this case is minus 1. The fourth one, please. How is it that x in this case has 1 over 2 as its coefficient. This is a bit more challenging because x in this case exists as a part of quotient, but we can rewrite quotients as products. How? If we see a fraction, we can split that fraction into 2 or more, and if we split them, they multiply to give us that same fraction. Okay, in the case of this x over 2, let me demonstrate why its coefficient, that is x coefficient, is 1 over 2. And here it comes. Please notice why we have to agree that x has 1 over 2 as its coefficient in this expression. See it here. X over 2 is the same thing as saying 1 times x over 2 times 1. If you condense 1 times x, you still get x. If you condense 2 times 1, you still get 2. What it means is that this, when expanded further, is this. And this, when condensed, will give us this. I hope that is clear. All right, let's continue. 1 times x over 2 times 1 can also be written as 1 over 2 times x over 1. This is correct mathematically because of a law of arithmetic known as associative law. If you learn about it, you will come to terms that 1 over 2 times x over 1 is the same thing as 1 times x over 2 times 1. So this, when broken further, will give us this. What it means is that x over 2, when expanded and written separately, will give us 1 over 2 times x over 1. I hope you can do a similar thing for other kinds of fractions that look like this, x over 2. Let's make progress. 1 over 2 times x over 1 is something as saying 1 over 2 bracket x over 1. It means therefore that when a number is written before a bracket and there is no sign between the bracket and that number, the sign is a sign of multiplication. So, though not written, what is here is a sign of multiplication. Let us then remove this sign of multiplication and condense these two to be like this. That is also correct, to be in this pattern. Something bracket something. This is 5 bracket 9. This is 1 over 2 bracket x over 1. Very soon, we learn that whenever 1 divides a number, the answer is that number. So when 1 divides x, the answer is equal to x. Therefore, this 1 over 2 bracket x over 1, when written without this 1, is 1 over 2 times this x. What we saw before as a quotient, which is x over 2, now exists as a product. The lesson here is that we can rewrite all quotients as products. Again, what is this 1 over 2 now doing? It is telling us how many x that we have. It tells us that we have half x, half of x. That is, x is just half, so half is counting how many x that we have. Since this 1 over 2, which is half, is counting how many x that we have, it has come to be a counter. And all counters in a product are called coefficients. Therefore, we conclude that the coefficient of x in this expression is equal to 1 over 2. I hope that this proof is clear to you. Let us see more examples of cases in which we have to isolate coefficients from products. Let us see. The first in our examples, that is more examples, is this expression 7g. In this, we want to find out the coefficient of g. Before then, let me inform you that this expression 7g is the same thing as saying G7. But G7 is not as popular as 7G. Whenever we have a variable written side by side with a constant, we always prefer that constant comes first before the variable. That does not mean that the variable is banned from coming first. So let me rewrite this 7G as G7. I have a reason for writing it that way. Later you'll find out. And here it comes, that this 7G is the same thing as G7. We ask, why is it that this and this are the same thing? Let me remind you of our foregoing case. Recall that 5 9s and 9 5s are the same thing. In fact, let me write that reminder. And this is the reminder. It says, recall, for instance, that 5 times 9 is the same thing as 9 times 5. Yes, bringing 9 into 5 is the same thing as bringing 5 into 9. Both of them will give us 45. Remember, the implication therefore is that 5 9s is the same thing as 9 5s. This is correct, both by reason and by law of commutation, which we see in course of time. Then it is possible that it is 5 that is missing and 9 is known. It is also possible that it is 9 that is missing and 5 is known. What it means is that in every product, it is not compulsory that the countee is always the one missing. The counter can also miss. And what is more, the counter counts the countee, and the countee also counts the counter. In other words, a coefficient of a countee can turn to be the countee when written differently. For instance, here, 5 is a counter and 9 has become the countee. That means 5 is a coefficient and 9 is a countee. Here, 9 is the coefficient and 5 is a countee, and they are both the same. The message is that in every product, any part of the product can be a countee, and any part of the product can be a counter. Recall that all counters of countees are called coefficients. Therefore, when recast, it means that a counter can turn to a coefficient, and a coefficient can turn to a counter. In any case, in every product, any portion of it can be a coefficient, and any portion of it can be a countee. I hope you know that this 7G is a product, and this G7 is also a product. This means 7 times G, and this means G times 7. Let me write statements concerning coefficients in both cases, or for both cases. The conclusion, therefore, is that the coefficient of G is 7, that is here, or even here, and also the coefficient of 7 is equal to G. It means that in every case of a product, any part can be a coefficient and any part can be a countee. For this statement, what we mean is that 7 is counting how many G's. In this statement, we realize that G is counting how many 7s. After all, G is a number, but because it is not known to us, we could simply call it a variable. But certainly, it is a number, and numbers count numbers. Therefore, in both cases, these statements are correct. In subsequent cases, I intend to de-emphasize the use of variables as being coefficients of constants. 7 is a constant and G is a variable. A constant is a number whose value is definite. A value that is known is stated to be definite. 7 is 7. It is definite. But a number whose value can vary or can change from one value to another value is called a variable. G is a variable, but certainly both of them are numbers. From now on, I intend to be using coefficients not in connection with variables being coefficients of constants. If a variable must be a coefficient, it must serve as that of another coefficient, another variable, not that of a constant. Not because it is wrong, but because we choose to de-emphasize that fact. Let us see another example. And this is example 2. We have 3xy. For this 3xy, we wish to tell the coefficient of y, the coefficient of x, and the coefficient of xy. Please think. What are the answers to these incomplete statements here? That is, could you tell what the coefficient of y is, what that of x is, and what that of xy is? What reasons do you have for your answers? Anyway, let me go back to the expression 3xy first. Is this a product? Surely. That means we can speak about coefficients because 3xy is a product. Every coefficient is a part of a product. There is something about this expression that makes it a bit different from the former ones. What is it? For the first time, we are seeing a product that contains more than 2 numbers. In the previous cases, we had just 2 numbers. Now the question is it feasible? The answer is yes. Meaning, can we have more than one counter for one countee? Surely, in a way. Let me show you an example that shows that it is possible to have a counter, that is a coefficient, which is also a product. Please watch out. Now, watch this example. It says, notice for instance that 18 fives, that is 18 bracket 5, could be written as this. That is, another way we can write 18 bracket 5 is 9 bracket 2 bracket 5. First, do you agree that this expression and this are the same in value? Surely you should. Why is it so? Because this 9 bracket 2 is the same thing as 18, because 9 twos is the same thing as 18. What it means is that I have further broken this 18 to be written as its products. 9 and 2, when multiplied, will give us 18. Therefore, 9 and 2 are the factors of this 18, which when multiplied will give us 18. And this 5 is still where it is. What it means is that if you say 9 times 2 times 5, the answer you get is the same thing as what you get if you say 18 times 5. The difference is that here we have only 2 numbers in a product, but here we have 3 numbers in a product. And don't forget that the 2 of them have equal value. This is to show us that it is possible for us to have a product that contains more than 2 numbers, and that it is possible for 2 numbers to join together and become coefficient of another number. In this case, 18 is the coefficient of 5. 5 is still where it is. What then is its coefficient? It is still 18, but no longer written as 18 in simple way. Instead, 18 is now written as 9 bracket 2. 18, a coefficient, is a single number, but 9 bracket 2 also a coefficient, is a double number. What it means is that a double number in a product can still serve as a coefficient. Don't forget our case in point. We say 3xy. If we are looking for the y's coefficient, is it possible for two numbers or more to become its coefficient? That is what we are trying to find out from this example here. And I believe that so far you have begun to believe that it is possible to have two numbers as a coefficient. If you don't want to express this 18 bracket 5, which is 18 fives in this form, you can even extend it further. Look at what it can turn to be also. 3 bracket 2 bracket 5. What was simple that contained only two numbers is now written to contain how many? 1, 2, 3, 4 numbers. There are several ways we can rewrite a given product, and the answer is not changed, and yet the number of things that partake of that multiplication changes from time to time. What is happening here is just a typical example. Here we have 3 things multiplying, but here we have 4 of them. But the value of this, the value of this, and the value of this will remain the same. Therefore, can we have even more than 2 in the product to become a coefficient? The answer is yes. Again, recall that the 18 is the coefficient of this 5. This 5 is still here. Then what is now its coefficient? These 3, when combined together, will still give us the same 18. Check it, please. 3 times 3 times 2. 3 times 3 is 9. 9 times 2 is that same 18. So this 18 is now written in form of 3 bracket 2. Now expanded, it contains 3 terms. When condensed, it contains just 1. Therefore, we can have 2 things combined to make a coefficient. We can have 3 things combined to make a coefficient. And obviously, we can even have 4, 5, and more combined to make coefficients. With that in mind, just know that it is possible to have more than one thing serving as coefficient. Now back to our foregoing case here. 3xy. We now ask, what is the coefficient of this y? To answer it, let's get back to the example I just left a short while ago. This 5, when isolated as a county, will have it that other things in that product will serve as its coefficient. So once 5 is taken away and seen to be a county, 9 and 2, when multiplied, now become its coefficient. When 5 is also taken away and it stands out as a county, 3, 3, 2 can also serve as its coefficient. Do not forget that all of these numbers are constants. None is a variable. But all variables are numbers, but not known numbers. Because of that, any of these numbers can turn to variables, can turn to x, can turn to y, can turn to z, can turn to g, can turn to e, just any alphabet from any language at all, not just English. Because of that, this 3x could have been 3 brackets 2, then times something, whatever it is. We don't know what x is, we don't know what y is, but they are numbers. Because of that, whenever a number is isolated from a product, all other terms, all other numbers in that product, apart from that number, serve as its coefficient. Based on that statement, if we isolate y from this statement, other numbers joined together become its coefficient. What then do you think is the answer to this statement? What will it be? Let me write it. It says the coefficient of y is equal to 3x. I believe that is what you were thinking. Yes, you were right. Once y stands as a counting, the rest stand as coefficient, and the rest here is 3x. What about this? Coefficient of x is equal to what? In like manner, isolate this x and let the rest become the coefficient. So what is the answer to this statement? Again, let me write it. And that is it. The coefficient of x is equal to 3y. So x isolated, so 3y becomes the coefficient. What about the last one? Coefficient of xy. What is it going to be? Okay, let me again contribute. And this is it. The coefficient of xy is equal to 3. Why is it so? If we isolate xy from this product, then the remaining one is 3. That counts how many xy we have. Because of that, these statements are correct, and I hope you followed all I said therein. Let this example serve for all cases of products that contain more than 2 numbers in a term. This contained only 3. In other cases, there could be 4, 5, 6, and even more numbers written together in a product. Please, let this example serve to make you know what to do in cases that contain more than 3 numbers in a product. Let us see another example, example number 3. And this is example number 3. We have expression like this: 5x bracket 3 minus c. And we ask, what is the coefficient of 3 minus c? What is the coefficient of x? What is the coefficient of 5x? You can also agree with me that these are not the only possible questions we can ask regarding this expression. We can work it out and bring out more questions as to what part serves as another part's coefficient. These 3 will be sufficient for us. First, I ask, what is the coefficient of 3 minus c? Before I go into it, let me inform you that this is a product. 3 minus c is obviously a difference, but because it is bracketed, we see it as one number. The point is that whenever anything is written in a bracket, we regard that thing as one number. Whether what is in the bracket is a term or not, as long as it is bracketed, we see a bracket as a number. From now on, please, if you don't know it, be it known that a bracket is seen as a number. Why is this seen as a product? The entire thing is seen as a product. It is because first, 5 and x, there is no sign between them. And so the sign is sign of multiplication. Since nothing exists between 5 and x, the sign between them, as we have known earlier by convention, is sign of multiplication. The next is a bracket. Not minding what the content of the bracket is, a bracket is taken as a number. 5 is a number, x is a number. Take this bracket also as a number. So how many numbers are multiplying here? It is 5, x, and the bracket. I will not say 3 minus c, though that is not wrong. I wish to say bracket for emphasis, because I just said that every bracket should be seen as a number. So in this case, it is 3 numbers that multiply to make up this expression. Therefore, 5 times x times bracket is what you are seeing there. As a result, this is actually a product. So we can speak about coefficients out of a product. All right, let us now take the first shot What is then the coefficient of 3 minus c? That is that of the bracket, because 3 minus c is the same thing as the bracket. The bracket, once isolated, that is 3 minus c, once isolated, will have other numbers serving as its coefficient. What are those other numbers here? They will be 5 and x. Therefore, what is the answer to this inquiry? Coefficient of 3 minus c. What is the place? Alright, let me write the answer and you compare it with what you were thinking. And here it comes. The answer is 5x. So coefficient of 3 minus c, otherwise coefficient of a bracket, is 5x. That is 5x tells us how many brackets or how many things that we have in the bracket. Okay, the next, coefficient of x. X is also a part of this product. Remember that 3 numbers appear in this product. What are they? They are 5, x, and bracket. Now, x is now isolated, and the rest in the product will serve as its coefficient. If others will serve as its coefficient, what then are you going to say is its coefficient? Let me also write it and you compare it with what you are thinking. And here it comes. The coefficient of x in this expression is equal to 5 bracket 3 minus c, just 5 times the bracket, and that is the answer. I hope what I wrote here is something as what you were thinking. If not, just come to know that this is the correct thing. Why? I said earlier that if you want to know coefficient of any count t from a product, isolate that count t and other numbers in that product will serve as its coefficient. X was isolated, so 5 and the bracket put together as a product will serve as its coefficient. The last one is that of 5x. If 5 and x together are isolated, what then becomes the coefficient? I'm sure that the answer has become obvious to you already. 2 out of 3 numbers which feature in the product have been isolated. They are 5 and x. So what then is going to be the answer? Let me again put it down and compare it with what you were thinking. And that is the answer. Coefficient of 5x is equal to the bracket, because once 5 and x are isolated, what remains in the product is the bracket, and that bracket is something as saying 3 minus c. Now let's see example 4. And this is example 4. The expression is x, y, z. This fourth example highlights the fact that sometimes a product may not contain a constant. In the previous examples, we had constants featuring. In this example 4, we have all variables featured. It is x, y, z. This will serve as example to help see how to tackle cases like this where everything in a product is a variable. The number of variables is not restricted to 3 as we are seeing. Instead, we can have more than 3, 4, 5, and more. So he will ask, what is the coefficient of z? But first, are you seeing x, y, z as a product? Surely by now, you should have known that this is a product. So as it is, if we want to get a coefficient out of a product, we isolate the count t and the rest serve as coefficient. This statement will help us to get the answers to these things straight away. The first one, if z is now isolated as a count t, what is its coefficient? The rest will become the coefficient. So what is the answer? Anyway, I know you're thinking about something. Let me tell what I'm thinking and what the answer is. And here it comes. It says that the coefficient of z is equal to xy. I hope you believe it. All right, next, coefficient of this y, what is it going to be? Once y is isolated, the remaining other parts of that product become its coefficient. So what is it going to be? Again, I ask, what is the coefficient of y in this expression? Again, let me put down the answer. The last one, please, says coefficient of yz. That is, we'll take this yz out of the expression. Whatever else remains in that product becomes its coefficient. So what is the answer to this? Coefficient of yz. What is it going to be? Obviously, the answer is this. Yes, the answer is x. All right, let us see the fifth and the last example. And here comes example number 5. This is the expression. It says 5xy over 2c. And from it, we ask questions: coefficient of x, coefficient of y, and coefficient of xy over 2. What do you think the answer to each of them is? Okay, let us start with the first one, coefficient of x. X is just here. What is its coefficient? We know that 5, y, c, and 2 remain after x is isolated. But are you going to say that its coefficient is 5y, 2c? That is absurd. First, recall that before we talk about coefficient, we talk about products. But this is a mixture of a product and quotient. Is it possible to express the entire thing as a product? The answer is yes. Again, let me inform you that we can reconstruct a quotient to be a product. This is a quotient, and we can do that. We had a case like that before. Recall x over 2, how it was tackled. This is just a case in like manner. 5xy over 2c is a case in like manner. Let us treat it the way we treated x over 2. How was it done? That quotient was reconstructed to be a product. Only after it was done were we able to tell the coefficient of x. Now, let us do the same thing to this. Now, notice how it was worked out. We want to reconstruct this to be like a product. Okay, look at this, 5xy over 2c, which is this. Where reconstructed will be 5 times x times y over 2 times c. I hope this is clear. All right, we're not going to do everything in detail, especially because it's only x we are targeting. So let us not go on trying to expand further other ones which are not x. Just the target is that x should stand alone as a part of a product, and let others still stay together. What it means is that we're not fighting to separate 5, y, 2, and c from others. Instead, we are fighting to separate x from others. Why? Because we are looking for the coefficient of this x. So if we start looking for that of y, we begin to fight to separate y from the product and let the rest remain where they are. Okay, now x is what we are targeting. Let it be isolated and let the rest remain where they are. So if the rest remain where they are, 5 still remains where it is, times this y remains where it is, but now times x stays separate from the rest. But know that when they are multiplied, they still give us what you have here and what you have here. It means that this expression is just the same thing as this first one when expanded. 2 and c maintain their positions because we are not isolating any of them. Now it is x that we're targeting. Now x stands alone as a part of a product. So we now have 5 times y over 2 times c. 5 times y, later you will learn, is equal to 5y. 2 times c, later you will learn, is equal to 2c. So 5 times y over 2 times c, when compressed, will be equal to 5y over 2c. Then times. This times is now removed, so that the next is just a bracket without anything that stands between the two brackets. When no sign stands between two brackets or between two numbers and are written side by side, mainly with brackets like this, the sign is sign of multiplication. So this is removed to reflect that we are multiplying here. So we have 5y over 2c bracket, this x over 1, which is here. I hope how this became this is clear to you. Now, something is beginning to show up. What is it? It is beginning to show that we have reconstructed this quotient as a product. Instead of saying a pure quotient, it is now something times something. Again, in a course of time, you will learn that whenever 1 divides a number, the result is that number. So when 1 divides x, the answer is system x, while 5y over 2c stands as before. Now, this expression is the same thing as this. I hope you are following what I'm saying here. If you are, please continue to follow. At this point in time, since this has become this, and this is something as our case in point, what then is the answer to this statement or to this question of what coefficient of x will be? All right. At this point in time, 5y over 2c is now telling us how many x that we have. Consequently, x, when isolated from a product as a county, will have other members of the product as its coefficient. This is a product. When x is now isolated, which numbers now form the other members of that product? It is now 5y over 2c. So the answer to this is what? Please, permit me to write the answer to this first inquiry. Coefficient of x is equal to what? Obviously, what is it going to be? It is this. Let me write it. And here it comes. Coefficient of x is equal to 5y over 2c. What about the next? Coefficient of y. The same thing will happen. Let me, in like manner, get the y out as a county and the rest as its coefficient. Please watch out. And here it comes. In our case, to answer this inquiry, we have it that this 5xy over 2c, when expanded, will give us this. It is 5 times x times y all over 2 times c. Now, what is our target? Our target is to keep this y as a separate member of this product when relating. That is why other members will remain where they are. 5 remains where it is, x remains where it is, 2 remains where it is, and c remains where it is. But at this point in time, by law of association, nothing is wrong with making this y stand out separately as y over 1. So when that is done, please, 5 times x is this 5x. That you learn later. 2 times this c is equal to 2c. That you also learn later. And then this times y over 1. This is clear to you because it was explained earlier. Now, at this point in time, when 1 divides this y, the answer is the same y here. So the whole of this as a product is also like this, also as a product. It means this bracket times y, I repeat, bracket times y. So whatever is in the bracket now becomes y's coefficient. So what then do you think? If y is now taken as a county, all the things that are found in that product will be called its coefficient. So what will it be? The answer is this. And that is going to be the answer to this inquiry of coefficient of y. Please, let me write that. And here it comes. The coefficient of y is equal to 5x over 2c. We can even do it without going through this long process. The long process is to make you understand why this came to be. But if you watch what happened here and what happened in the case of this second example, you can develop a short course of doing it without this long process. But the long process is why that short course will come to be in the first place. Let us look at the last inquiry, coefficient of xy over 2. And here comes the expansion of this 5xy over 2c in effort for us to find the coefficient of xy over 2. When expanded, it is like this. This is no longer new to you, I believe. And then, because of this inquiry, what are we going to set aside? We target the x, we target the y, and target the 2 to be put outside this product and let the rest remain where they are. That is why the thing is equal to 5 times this x times this y, see it here, over. What is it going to be? It is this c times 2. 2 times c is the same thing as c times 2. I believe you remember why. Okay, why did I have to rewrite it? It is for this 2 to be nearer the x, y, which is going to form the county. If 2 remains here and c remains this place, it will be difficult to reconcile what has happened here with reality. Right? Now we have x, y, and 2 near to themselves with x, y, and 2. The target is just to put them aside and as separate parts of the product. And that has happened here. So 5 and c remained where they were, while this x, y, and this 2 were set aside. Now look at this expression having been written as 5 over c times xy over 2. Before, written in this form, but now purely as a product, though each of the factors of the product stands as a quotient, but one thing stands out. It is now something times something. The question is xy over 2, which is here, when isolated as a part of this product, what then is its coefficient? Whatever remains after the isolation is its coefficient. So 5 over c becomes its coefficient. What then am I going to write here as the answer to this inquiry? It is this. Let that happen. And that is it. Coefficient of xy over 2 is equal to 5 over c, as we saw a short while ago. I think time has come for you to test if you have been following all I have been trying to explain in this section. And here comes the checkpoint. It says for each of the expressions that follow, determine the coefficient of the parts indicated. Number 1, 3 bracket 5 bracket 7. I hope you know the instruction and you understand it. Anyway, with the way the questions follow, you're going to get a sense of this instruction, if not gotten already. 3 bracket 5 bracket 7. I want you to isolate 7 from here and tell me its coefficients. Next, that is after doing it, isolate 5 as a county, that is this, and tell me its coefficient. So from here, tell me the coefficient of 7 and after it, coefficient of 5. Next, number 2, that is 8c. This one is very simple. It's just one part, not parts. That's why the s is in bracket. So isolate c and tell me its coefficient. Simple indeed. At number 3, we have 4yc. Isolate c and tell me its coefficient. The same thing for y, that is after, and afterwards the same thing for 4. Number 4, EFGH. Tell me the coefficient of h. After that, that of fg. After that, that of ef. Number 5, 7y bracket x minus 9. Tell me the coefficient of only one thing, just this y. Tell me its coefficient. The last but not the least, number 6, have 3gx over 5cy. Tell me the coefficients of gx and that of gx over c and that of 3x over 5cy.